Hello everyone and welcome to TechUptic. Today we are going to walk through the installation of Microsoft SQL Server 2025 and discuss how to configure it according to enterprise standards. We will be performing this setup in a domain environment. This means that we won't just stick to the default installation steps, we will also apply critical best practices, ranging from service account management and memory disk optimization to security hardening of the SA account and autogrow configuration. Our goal is to build a database infrastructure that is high performing, secure, and production ready. Let's get started. Before jumping into the installation, let's check the prerequisites first. On this page, you see the hardware and software requirements. On the left section, the hardware requirements are listed. For CPU, the minimum requirement is 1.4 GHz x64, but the recommendation is 2.0 GHz along with 4 vCPU and more. For the RAM, 1 GB memory is the minimum requirement, but 16 GB or more is recommended. For the disk, 6 GB is the minimum requirement, but we suggest separating the SQL data over multiple disks for best performance. In our setup, we will use 5 different disks. We will host the operating system and the SQL Server installation files under the C drive. For the SQL data, we will use the D drive, and for the logs files, we will use the L drive, and for the TempDB files, we will use the T drive. And finally, for the backup files, we will use the B drive. I also want to point out something. The hardware specs in the recommended section aren't set in stone. SQL Server's resource needs can vary a lot depending on several factors like database size, the number of concurrent users, query load, and the type of application. So you can think of these numbers as just a starting point. On the right section, you can find the software requirements. For the operating system, it can be installed on Windows 10 and above or Windows Server 2019 and newer. However, for production environments, it's a much better approach to install SQL Server on a current and supported Windows Server operating system if possible. Also, for SQL Server 2025, you need to have at least .NET Framework 4.7.2 installed on the server. Along with this, after the installation, we will install SQL Server Management Studio or SSMS to manage our SQL Server. And finally, we need to download the SQL Server 2025 installation media for the setup. SQL has different version options. In production environments, standard or enterprise editions are usually preferred. There is also a free version called SQL Server Express, but it comes with resource and feature limits. For test and lab environments, there are developer edition options, which are divided into two, standard developer and enterprise developer. These allow us to use the respective enterprise or standard features for testing and development, but they aren't licensed for production environments. Aside from this, the 180-day evolution edition can also be used for testing purposes. Therefore, when choosing a version, you shouldn't just look at your installation needs. You also need to consider the licensing model, resource limits, high availability requirements, and the specific SQL Server features you will be using. You can use the Microsoft SQL Server download page to get the trial and developer editions. If you are setting this up for a production environment, you can download the installation media from your organization's volume licensing or through the Microsoft M365 admin portal. You can find the links to both pages in the description section. On our next page, we have the network and other prerequisites. The most common connection port for a SQL Server default instance is TCP 1433. But for this port to be usable, the TCP IP protocol must be enabled on the SQL Server side, and the necessary access must be allowed on the network. If you are using a named instance, things are a bit different. Named instance usually use dynamic ports, and clients might need the SQL Server browser service to find the right port. The SQL Server browser service runs over UDP 1434. However, for a more secure and manageable setup, especially in environments with firewalls, it's a much more controlled approach to assign a static TCP port to the named instance and only open this port to authorized clients. Another requirement is internet access. While not strictly mandatory, it is very helpful for downloading SQL Server cumulative updates, the SSMS setup file, and other necessary additional components. You can install SQL Server as a standalone machine, but in corporate environments, joining the server to an Active Directory domain is a much better approach for access management, group-based authorization, and centralized management of service account. That being said, installing SQL Server directly on a domain controller is not recommended for security and operational reasons. Because of this, installing SQL Server on a separate member server is a much healthier design. And finally, service accounts are also important. As a best practice, you shouldn't run SQL services with highly privileged users or administrative accounts. If possible, you should use a GMSA, means Group Managed Service Account, MSA, Managed Service Account, or a virtual account. If those aren't suitable, using separate low-privileged domain accounts for each SQL service is the preferred way to go. Let's hop over to our server and start configuring the settings. To speed up our video a bit, we have already given our server a name, assigned a static IP address, and joined it to our Active Directory environment. In addition, we created two separate low-privilege Active Directory service accounts for the SQL Server Database Engine and SQL Server Agent services. For an account to run as a Windows service, it needs to log on as a service, right? When we enter these service accounts on the SQL setup screen, the installation process will automatically configure the necessary local permissions and the logon as a service right using our own installation privileges. So we don't need to do any extra work for these accounts. Now let's format our disks and get them ready for the installation. Let's close this window. Open the computer management and disk management. Let's initialize all of them. While preparing the disk, we will format all of them as NTFS, but for the non-C drives, we will format them with a 64 kilobytes allocation unit size. This is a widely used standard in the SQL Server world. We aren't expecting a magical performance boost here. The goal is to have SQL Server to work more consistently with large data files. So for the first disk, which is 40 gigabytes, let's start the process. Click Next. We will assign D drive for the data files. Click Next. For the allocation unit size, change it to the 64K. And for the volume, you can type data. Click Next and finish. The other 40 gigabytes will be the backup files. We set aside a separate disk for backups, but as a best practice, if possible, placing these on a different server or a dedicated storage device would be a much more better approach. Let's click Next. And for the backups, we will use the B drive letter and click Next. The allocation unit size again will be the 64K, and for volume, you can type backup and click Next to start the format. There are two 20 gigabytes disks here. We will use one of them for the log files and the other one will be used for the TempDB. Let's configure them accordingly. For the logs, we will use the L drive and change the allocation unit size as 64K and type as log for the volume label and click Finish. And for the last disk, make it TempDB. Let's assign the T drive here. Change the allocation unit size. Again, give it a name like TempDB for the volume label. Okay, our disks are all set right now. Let's check this PC. They are here. Okay. Now we are ready to begin the installation. Please make sure to connect the ISO file into the server and double click the setup exe. Let's close this window back here. On the Open page, on the left side, click the installation and then click the New SQL Server Standalone Installation or Add Features to an existing installation link. On the Edition page, there are multiple options. If you are going to use one of the free versions, you can choose them from the Specify a Free Edition here. But if you have a license, you can enter the product key from the Enter the Product Key section and choose the license type accordingly. Since we are installing it in a lab environment, we will go with the free edition, which will be the Enterprise Developer, and click Next. We need to accept the license terms. Please click here and then click Next. It is recommended that to use the Microsoft Update to check for the updates before installation. We will do it as suggested and click Next. The system checks some configurations in the background to see if there are any problems for the installation. We don't have a failed, but we have a warning for the Windows Firewall. But it's not a big deal because we will be configuring the necessary port permissions with a PowerShell script we will run towards the end of this installation. So we can just ignore this warning and hit Next. Now we are moving on to the SQL settings that require a bit more attention. On this page, it asks which features we want to install for the SQL Server. The best approach here is not to select everything, but only the features we need right now. On this video, we will only select the database engine services right now. This service is the core database engine of SQL Server. It handles storing, processing, and securely delivering the data. But if you need other features in your environment, you can select and install them based on your needs. Also, at the bottom of the page, you can see some directory information. These are just the locations where the installation files will be kept. In a moment, we will place the actual database files on those disks we created earlier. Let's click Next. In instance configuration, there are two options, default instance and named instance. You can think of an instance as a SQL Server engine or a separate SQL Server workspace. A single server can run a single SQL Server instance, or you can install multiple instances in a single server. Each instance has its own services, databases, system settings, and connections configurations. In our example, we are proceeding with the default instance. The standard instance ID for a default instance is MS SQL Server. If TCP IP is enabled and SQL Server is listening on the default TCP 1433 port, the connections can be made just using the server name. If you need multiple SQL Server instances on the same server, you can use named instance. Named instance mostly use dynamic ports. In this case, the SQL Server browser service might be required for clients to find the correct port. Alternatively, you can assign a static TCP port to the named instance and manage connections over that port. Especially in production environments, using a static port is generally more controlled and manageable approach. Since we are doing a clean, standard standalone installation in this video, we will stick with the default instance and hit Next. On this page, there are two tabs, Service Accounts and Collations. In Service Accounts, even if we don't touch these settings, the applications will still work. But since we joined the server to the Active Directory and are following best practices, we will make a few changes here. As you know, we created two separate low privilege service accounts in Active Directory. And now let's assign these accounts to the SQL Server agent and the database engine. Click Browse, make sure entire directory is selected and search for your account. Type its password here and please make sure to change start type as automatic. Make the same configurations for the SQL Server database engine. Click here, Browse. Select the appropriate account and type the password here. Because we are installing using a default instance, we don't need to enable the SQL Server browser service. We can keep it as disabled. And finally, at the bottom, there's an option that says Grant Perform Volume Maintenance Tasks privilege to SQL Server Database Engine Service. This option allows SQL Server to take advantage of the instant file initialization feature. Instant file initialization (IFI) can save you some serious time, especially during data file creation, autogrowth, and restore operations. Because of this, enabling this option can be beneficial for performance, but it should be evaluated according to your company's security policies. That's because, theoretically, there is an information disclosure risk, such as being able to read data remnants from previously deleted disk contents. Maybe this is an acceptable risk in many environments, but it still shouldn't be turned on blindly. On this instance, we are enabling this option. Before going on to the next page, let's check the collation section. Another setting that shouldn't be skipped over blindly is collation. Collation determines how characters are compared, sorted, and whether they are case sensitive or access sensitive in SQL Server. The most important criteria here is what collation value the application you are installing requires. If SQL Server is being installed for a specific application, you should always check the vendor's documentation first. If some applications aren't installed with a specific collation, you might run into data comparison, sorting, and reporting issues during setup or down the road. If the application doesn't have a specific requirement, you should use the organization standard collation value. If there is no corporate standard, then you should make a decision by evaluating the language, region, case sensitivity, and access sensitivity needs. We will change this setting from Turkish CIAS to SQL Latin 1 General CP1 CIAS, which is commonly used in many environments. Let's click Customize, and from SQL collation used for backward compatibility, let's find the appropriate collation. This one. Even it is commonly used, I highly recommend choosing whichever one fits your environment's best needs. Let's click Next. There are many tabs here. In the first one, there is a server configuration. We determine which authentication method will be used to connect to SQL Server. Mixed mode allows use both Windows and the SQL authentication. However, in environments where it is possible, moving forward with Windows authentication mode is much more secure and manageable approach because we can handle user and group management straight through Active Directory. So I am selecting Windows authentication mode here. In the section below, we need to specify the account or group that will have sysadmin privileges on the SQL Server. Instead of using built-in and highly privileged groups like domain admins, enterprise admins, or maybe built-in administrators here, the best approach is to use a dedicated Active Directory security group created purely for SQL management and add relevant members to that group. For this purpose, we already configured a custom group in our Active Directory. Let me show you. Here, we created SQL-DBA-admins and add the respective members here. And let's choose here to grant access for this group's member. Okay. The next step is related with the data directories. You could install using the default directories. It will run without any problem. But since our goal is to build a more organized and manageable structure, we are going to make some changes here. First, let's create some specific folders on the disk we prepared. Let's go to this PC. I will use MSSQL folder on each disk root section. Let's create a folder, SQL, and copy that to all disks. And then I will create some other folders under specific drives. For the D, I'm going to create data under MSSQL folder. For the L, I will create log folder under MSSQL. And for the B, I will create backup folder under MSSQL. And for the T, I'm going to do the same thing for TempDB. Now let's place in the appropriate fields on the setup screen. For data root directory, we will target it to the MSSQL folder. For the user database directory, we are going to target the data under it. For the log directory, we are going to use the L drive and log folder under MSSQL. For the backup directory, we are going to use the B drive as targeting the backup folder. With these settings, we are leaving the operating system and the SQL Server application files on the C drive. We are moving the user database files, data files, to the D drive and the transaction log files to the L drive. The reason we do this is that the I/O behaviors of data and log files are different. While data files generally show more random read-write behavior, transaction log files have a more sequential and write-heavy nature. Therefore, placing these files on separate disks is much better approach. We also use the B drive for backups, but as we mentioned earlier, in production environments, it is better to store backups on a different server or a dedicated storage area rather than on the same server if possible. And finally, it is worth noting that in our current lab environment, these disks were created over the same physical storage. In production environments, just creating separate drive letters at the OS level isn't enough on its own. The underlying physical disks, RAID structure, SAN, and redundancy design are at least as important as directory separation. Let's continue with the next step, which is TempDB. TempDB is the system database that SQL Server uses for temporary tables, sorting, hashing operations, and some background workloads. Leaving TempDB too small and consistently forcing it to autogrow is not a good approach. That's why we need to size it properly from the start. In this lab environment, we allocated 8 vCPUs to the SQL Server. Microsoft's general recommendation for systems with 8 or fewer logical processors is to start with a TempDB data file count equal to the number of processors. This is why we are creating 8 TempDB data files here. The important thing here isn't just the number of files. These files also need to start at the same size and have the same autograph value. This way, SQL Server can use these files more evenly. I am setting the initial size value to 512 megabytes here. So with the 8 files, we are starting with a total of 4 gigabytes of TempDB data space. This 4 gigabytes value isn't an official or universal best practice. It's just a control starting value we choose, so we don't leave TempDB at the tiny default of 8 megabytes in this lab environment, where we don't know the real workload yet. In production environments, TempDB size should be determined by monitoring the application's temporary space usage, query intensity, index operations, or so on. For autogrowth settings, using a fixed megabyte value is a predictable approach, so I am setting the autogrowth value to 256 for each TempDB file. However, autograph is not a capacity planning method, it's a safety mechanism for unexpected situations. The right approach is to size the files as accurately as possible right from the start and avoid constantly relying on autogrowth. For TempDB log file, I am setting the starting size to 1024 megabytes. And the autograph value will be the 256 megabytes. We don't want to leave the log file too small because log growth operations can cause short delays in busy systems. And finally, we are placing the TempDB data and log directories in an area separate from our main user database files. To do this, I am directing both of them to the T drive. Just click Add and target them to the respective folder here and remove the old one. Okay, with these settings, we can continue with the next step, which is MAXDOP. MAXDOP determines the maximum number of CPU cores a single query can use at the same time in SQL Server. The goal here isn't just an arbitrarily speed up SQL Server, but to make the CPU usage of queries much more controlled. Microsoft's general approach is to set this value based on the number of processors and then monitor it according to real-world usage. In systems with 8 or fewer CPU cores, The MAXDOP value can usually be set equal to or lower than the core count. In larger environments, a value of 8 is considered a starting in most scenarios. Since we have 8 vCPUs in our lab environment, we could have this to 8, but because we want to start off more controlled, I am going to set this setting as 4. We can say this setting is definitive or correct value for every environment. That's why after making the initial settings, we need to monitor the CPU consumption and query performance in the actual environment, then adjust it as needed. Let's continue with the next tab, which is memory. If SQL Server's max server memory value is left at the default, the SQL Server can use a large portion of the server's RAM as it needs it. This doesn't mean it will instantly consume all the RAM all the time, but when enough memory isn't left on the operating system and other components on the server, it can cause performance issues. That's why we use the recommended option here to set an upper memory limit for SQL Server. This setting caps the maximum memory SQL Server can use and help us leave some memory for the operating system. I am also leaving the minimum server memory to 0 MB. Because minimum server memory doesn't mean SQL Server will immediately reserve this much memory as soon as it starts. Once SQL Server reaches this level, it tries its best not to drop below this limit. Since we are running a single instance in this lab environment, I don't see a need to increase the minimum server memory. Memory settings made during setup are also just a starting point. In production environments, these values also should be monitored and adjusted later according to your needs. And finally, for the systems to apply these settings, we check the box that says click here to accept recommended memory configurations for the SQL Server database engine and move to the final tab. The final tab is the FILESTREAM. FILESTREAM is a powerful but niche feature which allows SQL Server to store large binary objects like documents and image files integrated directly with the Windows file system. This setting should be enabled based on the needs. For example, if there is large BLOB data in the environment, if the application supports it, or if fast streaming access is required, this feature can be turned on. Since we don't need this kind of feature in our setup and we don't want to create any unnecessary management overhead, we are just leaving the settings off and click Next. With that, we have completed the technical tabs of the installation wizard. Now we can start the SQL Server installation. Let's click Install. The SQL Server installation is finished. As you can see, the features we selected appear to have been installed successfully. But just to verify the overall status of the installation, let's take a quick look at the summary log file. Let's click here. And as you can see, under the overall summary, the final result is passed and the exit code 0, which means installation process completed perfectly. Overall, the installation looks successful. Now we can move on to our basic post-installation checks. Let's close this and close this. Now we are going to run a PowerShell script where we will perform some essential post-installation checks for the default instance. Let's create a folder under the C drive. I will call it temp, and under it I will create a text file. Let's copy our script here. Before running script, I will explain what it does. This script checks the SQL Server and the SQL agent services on the server, the accounts those services are running with, the TCP IP protocol settings, and the required port rule on the local Windows Firewall. During this check, if the SQL Server TCP IP setting is disabled or the TCP 1433 port configuration is missing, it automatically fixes it. Likewise, if the required inbound rule doesn't exist on the local Windows Firewall, it creates a rule for it. Let's save it and change its extension from txt to ps1. Let's run a PowerShell with administrator account and go to this directory first and run the script. As you can see, for the SQL services and accounts, it identified them as running with the specified accounts here. For the TCP IP protocol and static port checks, it's a success. And for the local Windows Firewall inbound rule, it says it is allowed. So our scripts run perfectly. If you need, you can also download the script from our websites as well. Now we can move on to the installing SQL Server Management Studio or SSMS. SQL Server Database Engine is the core database service. SSMS, on the other hand, is a separate management tool that connects to this service and allows us to manage the SQL Server Database Engine visually. So it doesn't automatically come with the SQL Server installation. It needs to be installed separately. We can download the setup file from the Microsoft official website. I'll be sharing the link in the description section as well. Click the Download SQL Server Management Studio 22 installer, which is the most recent one. Let's double click it. Let's close the Google Chrome and close these windows here. In this new GUI, we don't need to select anything additional package. We just need to click the install. The Management Studio installation is completed. The prompt recommends that we restart the server, but we can do it later. Let's open the application and connect to our new SQL Server instance. Here we need to make sure that the user making the connection is a member of the specific SQL admin AD group we added during the SQL setup. Here we can select skip and add accounts later to bypass this option. As you remember, the SQL admin was the member of the respective custom group. So I log in with this account. Let me check if I log in with this account. Yes, I am the member of this group. And as you remember, we use the default instance and we can make a remote connection as using the host name. And we are going to use the Windows Authentication. For the encryption, let's make it optional and click the checkbox for the Trust Server certificate and click Connect. We are connected to the database. Let's run a quick query to check the version details. Let's open a new query window and type select space add version and execute. As you can see, in the output section, we can clearly see the SQL Server 2025 version. This shows that we successfully connected to our SQL Server instance and can run a basic query. With this final check, we have come to the end of this video. I hope you found it helpful. See you on the next one. Take care. Bye.